So today we are going to learn what is not biodiesel. In this, what we are going to do is we are going to see, in addition to what is not biodiesel, we are going to see why we cannot use fatty acid as fuel. And then we will see what are free fatty acids, and then we will again look into transesterification. If you remember last presentation, then we have seen these two molecules, and I told you that these two molecules, biodiesel and diesel, have similar structure. That's why we can use this as a biodiesel. What if I tell you there is a 1 mole molecule which may have a similar structure like these two, but we do not use this as a fuel. This is a fatty acid. We will look more into it. And biodiesel is what I have shown. The molecule which I have shown here is fatty acid methyl ester. So it is called FAME also. So this is a hydrocarbon chain of fatty acid, and this is an ester. So this is a methyl. So that's why this is called fatty acid methyl ester. So what is a fatty acid? It's a carboxylic acid with a long chain of hydrocarbons. This is the molecular formula CH3CH2X COOH. So this is a carboxylic acid, and X is number of carbon atoms in the hydrocarbon chain. For most of the fatty acid, X is even, and the number for the carbon atoms in a fatty acid is 4 to 36. A typical fatty acid contains 12 to 18 carbons. So let's see why we cannot use this fatty acid as a fuel. Now, fatty acids are acids, and therefore, though it is mildly acidic, but over a long period of time, it can cause corrosion. And this corrosion may be metal parts or where you are producing these fatty acids, and whereas esters do not cause corrosion, right? Another reason is that fatty acids has lower Cetane number than fatty acid methyl esters. So let's see why this is very important. Let's see what is Cetane number, and then you will come to know why the Cetane number is very important in case we burn fuel in a diesel engine. Cetane is a chemical compound with a formula C16H34. And since it ignites very easily, so a Cetane number of 100 is given to cetane, and a number 0 is given to alpha methyl naphthalene. So since fuel consists of different components and each component may have different Cetane number, so average of different Cetane number is taken as a fuel Cetane number. Now Cetane number tells us about tendency to auto-ignite in a diesel engine. If a fuel has a higher Cetane number, it means shorter ignition delay. And if it has a lower Cetane number, it means a larger ignition delay. So what does it mean? It means if you have a higher Cetane number, then there will be quicker ignition. Quicker ignition means there will be less buildup of non-ignited fuels inside the combustion chamber, and there will be a complete combustion. So all this will lead to quicker starting for vehicles. So engine will operate more quietly, and fuel efficiency is more, and less emissions are there. This all is regarding if the fuel has higher Cetane number. So let's come to this. So fatty acid methyl esters have higher Cetane number than that of fatty acids, and also they doesn't cause corrosion. These are the two major reasons why you do not use fatty acids in diesel engine as a fuel. So we have covered this. What is not a biodiesel? Fatty acid not a biodiesel, though it has a similar structure, and why we cannot use fatty acid as fuel. Now let's see what are free fatty acids, and then we'll look into transesterification also. So free fatty acids are non-esterified fatty acids. So these are present in crude oil also, and also these are formed due to frying in the presence of moisture in the foods exposed to the oil. Fatty acids are formed from the triglyceride, triacyl glycerol or triglycerides. So these may be present in the vegetable oil or grease or the frying oil which we are using, or it is formed during the reaction. Fatty acids are formed from triglycerides. It may be due to extreme heat or enzymes. Then triglyceride may break into diglyceride with one free fatty acid, or it can produce two free fatty acid with one monoglyceride, or it can produce three free fatty acids. Let's see what is a triglyceride, which we have seen earlier also. This is a triglyceride, and you can see the fatty acids along hydrocarbon chains, and which is an ester, and there is a glycerol molecule here. And normally this hydrocarbon chain, in various books you will see the hydrocarbon chain which is here is written as R, where R is a radical. So you can write this, replace this chain as RCW. So this triglyceride looks much cleaner in this form. Also, you can have a different hydrocarbon chains here. So you can have a different hydrocarbons here, different here. So then in that case, here you will get R1, R2, R3. So that's or R dash, R double dash, R triple dash. That's what is written in various books. You have seen this transesterification reaction in the previous video also. If we use R in place of this, you see this reaction becomes much simplified. So it's a much cleaner look here. Similarly, you can write R here in biodiesel also. If there are free fatty acid present during transesterification process, then these will react with sodium. If moisture is present, these will react with sodium to form a soap. So this is soap. So free fatty acids in presence of water can cause soap formation. Fatty acids are not strong acids, but still they react with strong bases to form salts, which is called soap. Why this soap formation while production of biodiesel is a problem is that because it reduces effectiveness of catalyst like sodium hydroxide or potassium hydroxide, and also this will yield in low conversion. That means less biodiesel will be produced. If the soap is formed, you need to separate it and then clean the product as well as the catalyst. If soap is formed, that means the material and energy cost will be high. So that's all for today's presentation. Keep learning. Thank you very much.